Hi, I will introduce our group member, which is our group member consists of 5 people, which is me, Muhammad Hazim bin JUMALI. Second, Muhammad REZQAL bin RAMLAN. Third, Muhammad ADIB SYAHMI bin Muhammad SHAHRUL AMRI. Fourth, HAZIQ IMAN bin Muhammad AZMIDAR AFFANDY. Fifth, IMULIANA bin YASIS. Hi, now I will present introduction part. Two of the primary related fields of dynamic are kinetic and kinematic, which is in our topic. Kinetic and kinetic are two fundamental concepts in the physics that describe motion and the force behind it. Kinetic focus on the force that causes an object to move, while the kinetic examines the motion itself without the considering the underlying force. Kinetic study how the force such as gravity, friction, and applied force influence the motion of the object. Force, momentum, energy, and work is the example of the concept. Not only that, kinematic is the branch of the physics that study the motion of the object without considering the force causing the motion. Focusing on position, velocity, and acceleration is an example of the concept. On this part, I will explain about objective. We have four objectives, which is first to identify and qualify an engineering case study from the real life that deal with the rigid body motion. Second, to develop a kinetic and kinetic analysis system to study the projectile motion of the goal box, which is our case study. Third, to evaluate the chosen case study that involve performing necessary calculation, analyzing the outcome, and determine how successful the selected methodology was. Fourth, lastly, to conclude the understanding the application of application kinetic or kinetic of the complex engineering problem in the real application.
Hello, my name is IMULIANA binti YASIS and I will present about the case study description. As for our case study, we will explore the design and implementation of a mechanical golf swing that uses kinematics and kinetics principle to improve the swing efficiency and to relate in real life application. We choose this case study to examine the projectile motion. So the main focus is to studying the movement of golf balls as a highly visible and follow predictable motion paths. So our goal is to utilize the principle of Newton's second law, work and energy, impulse and momentum, and direct impact. Next, we go through the experimental design. So here we have the apparatus and materials, which is we have the golf balls, protector, measuring tape, high-speed camera, data acquisition system, force sensor, and accelerometers. For the procedure, first set up the launch mechanism. Second, accurately set the launch angle using a protector. Third, place high-speed camera and motion sensors. Fourth, connect sensor to the data acquisition system. And for data collection, for initial measurement, first measure the mass of golf balls. Second, to calibrate the launch mechanism. The experiment. First, launch of golf balls at various angles. Second, record time and the trajectory. Third, measure range and collect force data. And the last one is to repeat the experiment several times by ensuring the data accuracy and reliability. So here are the equation that we use in our case study. First, we use the kinematic analysis is to calculate the position, velocity, and acceleration. Second, we use the kinetic analysis, which is first we apply the second Newton's law, F equal to ma. Second, work done and energy transfer, which is 1 over 2 mv2 power of 2 minus 1 over 2 mv1 power of 2. Next, we use the impulse momentum, which is mv1 plus imp equal to mv2. And the last one, we use the coefficient of restitution, which is V prime B minus V prime A over VA minus VB. V prime B is the final velocity of B and V prime A is the final velocity of A. Meanwhile, for VA and VB is the initial velocity of A and B.
Assalamualaikum. Now we move to the calculation part. But before that, I will introduce myself. My name is Muhammad REZQAL, and today I'll be presenting to you about the calculation of our case study. So in this part, we will cover about the calculation of the velocity of the golf ball after being hit by the golf stick, and then we also will cover the impulse force after the ball being hit, and we also will discuss about the when the ball hits the ground after falling, and lastly we will cover the impact between golf stick and the golf ball. So let's jump to it. So let's start this part with a simple analysis on our case study. So our case study is a person hitting a golf ball from a distance, which is the distance from the ball being hit and the to the landing point is 300 meters with a 30-degree angle, and the highest projection of the ball is 50 meters. So we start by using the equation of motion on x direction, and we will get the first variable, which is the initial velocity, and it will be the equation 1, and then we continue our calculation by using the equation of motion, but this time on the y direction. And then in this calculation of motion on y direction, we will get the second equation, and after solving the second equation, we will get the total time, the time of the ball hit the ground after being hit by the golf stick, which is 6.19 seconds. And then we finish this part by substituting the third equation into the first equation, and then we will get the initial velocity of the ball after being hit by the golf stick, which is 56 meter per second. So now we want to find the impulse force of the ball after being hit by the golf stick. So we will use the impulse and momentum equation, and given that our mass of the ball is 0.045 kilogram and v1 is equal to 0.5 meter per second, and we substitute the v1 and the v2 and also the mass into the equation of impulse and momentum, and we will get the impulse force of the ball after being hit by the stick, which is in this case is equal to 5.04 Newton. And we close this calculation section by calculating the impact between golf stick and the golf ball. We use the principle of work energy, which is T1 equal to 1 over 2 mv, and then T1 minus T2, you will get the work of the system. So in our case, the work or the impact of the ball after being hit by the golf stick is equal to 1.26 kilojoule. So that's all for the calculation part, and we already covered all of the objective for this part, which is we want to find the impulse force after the ball being hit. We want to find the velocity of the golf ball after being hit. We want to find the time of the ball to hit the ground. And lastly, we want to find the impact between the golf stick and the golf ball. So that's all for calculation part.
Okay, now I will continue with discussion. First of all, my name is Hazim IMAN bin Muhammad bin AFFANDY. So, for motion analysis, first of all, we need to define the horizontal and vertical data. For horizontal, we can get distance by speed multiplied by times, and for vertical, we need to consider only the gravity. So, we combine those two to solve for initial value and time of flight. For impulse and momentum, to find force, we need to use impulse momentum principle to get the force data. And calculation that we use in impulse and momentum is to find average force is by mass times change in velocity. For work and energy, for work energy changes is compute kinetic energy before and after the hit. For conservation and work and energy is initial kinetic energy to work done by force. In order to success make this report success, we need some consideration, which is errors and verification. For errors, high initial velocity may indicate error, and for verification is we need to check the calculation and assumption. So conclusion for discussion is first is interaction. Interaction that involved in this project is kinematics, dynamics, and energy in projectile motion, and challenges and error in calculating the initial velocity and forces. Thank you.
So the conclusion is, in this study, we analyze golf ball motion using Newton's second law, work and energy principle, impulse and momentum, and coefficient of restitution. High-speed camera and motion sensor enable precise measurement of trajectory and velocity. Result confirm theoretical prediction of initial velocity and trajectory accuracy, validating our experimental approach. This study underscored the integration of theory and experimentation to optimize golf swing performance and enhance training aid for better technique and performance outcome.